I was like 15, so I was growing up in New York and struggling in this kind of new setting where I was a gifted kind of student in math and science and things like that, and then I went to a school for gifted students, and that was weird. And I kind of also was growing up pretty fast at the same time. I had some troubles at home, and I was also had a bad case of puberty. So I kind of wanted to get away from the whole learning for learning's sake, and wanted to move more into some practical applied field. And the opportunity came to join a hedge fund, and I, like anyone who likes math, probably, or science, the markets are a fascinating kind of, speaking of math, right, they're almost like a Markov chain or something like that. And
Right.
what's amazing is that these days all the top old hedge funds like Tudor and others are closing or shutting down their human divisions and growing their AI divisions. And a lot of, obviously,
That's right.
the very most successful stock pickers are just math programs and designed by mathematicians and other big data kind of applied science type people. And it's, for me, just the allure, just the beauty. It's like almost like what Ramanujan would talk about, like the beauty of the numbers in and of themselves was attractive. That basically what finance is watching and predicting a bunch of random numbers all the time. And that in and of itself was kind of intoxicating. And then the fact that when you couple my first jobs were related to pharmaceutical analysis. And so you had this other applied science that was really neat, and you still had that kind of mystery and magic of math, even like little things like geometric return of like, if a portfolio goes down 50%, I would quiz people in the office, what return do you need? Portfolios, put another way, like a corollary would be, if a portfolio drops 50% and then rises 50%, what value is that portfolio?
Yeah.
And you'd be surprised at how
That's why,
how many people sit there and say, well,
yeah.
should be.
I mean, that's, who was that? I think it might have been Ben Graham, who was one of the first people to say that, a dollar loss is worse than a dollar gain because you need to make additional money
Right.
to kind of make up for that loss. So,
Yeah, and a lot of
I guess.
a lot of that stuff is really kind of like, it's a little bit of, it's the cross section of like pretty simple math and amazingly deep intuition. And like I do this thing that very few people do. I worked with Bloomberg on actually building this function, which is crazy. It's called a historical return histogram, and it's one of the least used functions in all of Bloomberg. And all it is a PDA, a probability distribution function of one day returns of that security for however long you want to go back. And it builds you a quick, like, here's what 1 sigma is for this company, here's what 2 sigma is for this company, etc. And just as simple as looking at that and pointing to someone like my boss and saying, look, this stock has never moved more than 3% in a day in like 5 years. Like, why are we trying to predict what's once a 1 sigma move or a 2 sigma move is inconsequential? And if you sat there and you look at it and you're like, I guess so, and it takes that kind of like the marriage of like this really simple intuition and this relatively simple math, and then you say, that's a really important insight. And that's another reason I like finance. It's in mathematical language, but it has this abstract meta nature to it that's kind of profound.
Right. Going off of that, one of the things that the questions that arises for me there is everyone has access to these mathematical tools. Everyone's got the SEC publications. Everyone's got access to the same information, more or less. What distinguishes those, average investors from those great ones? Because the move you just described was, in some terms was rather banal. It was just looking at certain things. But what are kind of the barriers to being a great investor?
Well, I wish I knew. I think a couple interesting theories. Like, so if you take basic calculus, and the whole notion of a limit has always puzzled me so much that I named my first hedge fund Ovia. It wasn't a successful hedge fund, unfortunately, but it was the only business that I started with other people's money that didn't succeed. Thankfully, I made sure that those initial investors were compensated later. But interestingly, the Aliyah, Zeno of Aliyah's his paradoxes, right, were the whole idea of a limit was sort of generated in 300 BC by Zeno. Even though he didn't call it a limit, he really got to the essence of a limit, and obviously Newton and Leibniz and those guys figured it out. But in stocks, I like to call them Martin's conjecture. It's very humble, but however you can make that humble, please try, because it's pretty stupid. But basically, I like to say that if you call alpha the dispersion of a stock from its true value due to market forces, like whatever it might be, just like emotion or whatever, then, and you call like time a variable. So as time goes to infinity, alpha should drop to 0. And alpha is a coefficient with beta or any other unknown factor. Then you could argue that as time approaches 0, the other direction, then the amount of uncertainty should approach 1, and the amount of alpha should approach 0. So if you just take it down to like a millisecond, there should be no way to reliably predict a millisecond. Same way you probably can't predict where an electron will be or something that second. But over enough time and with enough information, if time stood still and you just got to study a stock, you could probably at least probabilistically come up with a fair value that is a reasonable approximation. So I think the trick with the markets is that humans have finite amount of time. And if you just get more humans, then you have an issue of training. Because maybe you're a great investor, but not everyone you hire is going to be a great investor, and it takes time to train those investors. So the real paradox of investing is that you don't have much time to analyze these securities, and if you don't analyze all of them, then you have this selection problem where you have 5,000, let's say, publicly traded equities in the United States. Well, which one do you start with? So it probably will take you many, many hours, if not even days, to study one stock. Well, you have 365 days in the year. So at best, maybe you can study 50, 100 stocks in a year, and that's moving really quickly. Well, then how do you know that of those 50 you've looked at, that the opportunity, or the alpha, if you will, wasn't randomly located in a cluster of the other 4,950 or 4,900 stocks? And it's maddening if you actually sit down and think about it. And the problem I had with hedge funds is when I saw the way hedge fund managers, quote unquote, managed, it's remarkable. I mean, basically, they sit down and listen to, they hear pitches from brokers or other investors or things like that. What they don't do is say, okay, well, these are the 5,000 stocks that we're supposed to be looking at, and here's how we're going to divvy them up. And a reasonable way to do it would be something like, well, I'm just going to look at healthcare stocks because and I'm going to hire healthcare experts, or similarly in, say, technology, where I'd only look at routers and semiconductors and software and things like that. And that immediately narrows down the pool dramatically. And then if you truncate it other ways, like, well, I only want really liquid stocks or something like that, you're really talking about an actual achievable pool. The problem is that the way they distribute their time over that pool is also inaccurate. So, in my eyes. So what you really have is like this actually investing could actually be rather easy if you think about it from one perspective. The hard part is actually managing your time and your own kind of willpower to actually sit there and be mathematical and reasonable about it. Like what I often find is people always come to me and say, oh, Martin, I found this amazing stock, this amazing drug stock, and it's going to go up 1,000,000-fold. And I sit there kind of amused and I say, how many drug stocks have you looked at and passed on? Such that this is the one that is amazing. And can you list me those stocks? And I always get this sort of confused look where people say, well, I've only looked at a few, or I haven't looked at any, or whatever. And I'm sort of sitting there like, well, how can you tell me that mass therapeutics is the next big thing when, in fact, you've looked at one drug stock? After you look at 700 drug stocks, you tell me that this one is the one. Then I'll absolutely put $5 million or $10 million into it. But until you do that, how could you possibly logically conclude, all of this. And I actually owe, I'm sure you're not curious about this, but I'd love to talk about it real quickly, is that I actually owe all of this sort of logical framework to my 7th grade math teacher, Linda Abudi, who actually, at Hunter College High School, who actually taught us symbolic logic at 12 years of age, and 11 and 12 years of age. And she taught us De Morgan's Law and conjunctions, disjunctions, etc., tautologies, syllogisms, everything. And ever since then, I've thought in this, like, what I hope to be this immaculately precise and logical way. I'm not always right, and I certainly made my share of mistakes. But it's amazing to me how a huge chunk of finance isn't exactly robust logically, and that might be why these sort of hedge funds that use their brains instead of their machines are not succeeding as much as they used to. So anyway, that's a long-winded answer, but I hope that helps a little bit.
Absolutely. I mean, if I can just slip in one more comment on that, I'm really glad you mentioned that whole logic thing, because I recently noticed, when I was in high school, there was a very high correlation between how smart you were perceived to be and how good you were at math. And I always thought that, smart people, they're good at math. Smart people are good at math, they're good at science, etc. Now I've met more people, and I've come to realize that really smartness and the ability to make good decisions are rooted in a very solid understanding of logic and mastery of such. And you can find people in literature and whatever that are amazing at logic, and that are able to deduce facts, deductive, inductive abilities absolutely on par, but just can't wrap their minds around mathematical objects. It's just kind of the frame of mind they're in, but it doesn't preclude them from being intelligent. And I feel like a large part of that is also emotional intelligence, which at face value might seem to be rather frivolous and not really rooted in rationality or logic, but I guess the way you deal with the input you get from your gut or something else, and kind of how you distill that information does require great logical powers. And I have a hunch that a lot of great investors capitalize off of that skill.
Yeah, no, I think that's right. I mean, so Descartes. People ask me sometimes, who would you go back in time and meet? And Descartes is maybe my number one choice. And Descartes was just like this truly gifted thinker, and all these great old thinkers were gifted not only in logic and math, but also their other disciplines. Right? Look at Descartes, for example. The guy conceived of the Cartesian plane, which to me is like the most miraculous, brilliant. I mean, and you're talking about like people have played with numbers for thousands of years, and this guy says, "What if we plot them?" And it's just this unbelievable, insight. And then the guy also is this tremendous writer, and amongst other things. And you look at someone like, at least in terms of logic, his Reductio ad absurdum certainly changed my life, and in terms of how to solve problems. And then Jacobi with his math was mostly forgotten in modern times, but you learn a little bit about it in calculus. But
super important now, because you've got these things called Jacobian matrices that use first order differential approximations of things. So basically, you take, especially in finance, it must exist, somewhere in those quantums.
Yeah,
where you take these, you've got these equations, your regressive variables, cubic, quartic, etc. You just approximate it linearly, and you use Jacobian matrices to kind of try to predict the stock price, how it unfolds based on market forces.
Well, I didn't know its application in finance. I just remember it from like Calc 2 or something. And then Jacobi said, always invert, as this general problem-solving solution. So a lot of people ask, like, how do you be successful? And I always say that, well, Jacobi and Descartes would say go backwards. And I think that's a really tough thing for people to do mentally, because they're starting on this, like, maybe the way I started, a poor kid in Brooklyn with 3 pairs of pants at best, and trying to reach some other pinnacle, whether it's intellectual achievement or financial achievement. And what a lot of sort of really successful people say is they sort of self-actualize. I know Steve Cohen, who is one of the greatest investors ever, likes to say that, or at least if you've read the precious little he's written, is that he sort of just imagined his success and kind of worked backwards. And I think that if you have a big enough mind, you can kind of do that, and you sort of see the steps that you need to take to get from point A to point B. And faith is very important. You have to actually see that success in your mind and actually believe that you can do it. And then once it's less scary, a lot of people are always like, "Oh, weren't you afraid in Congress, or weren't you afraid when you got arrested?" Like, I don't think I've ever been afraid in my life, because in general, like, I almost like expect like the most unexpected, crazy, salient things. Like, you know, some of my biggest like investments or greatest successes, like, are I'm always meeting them with a shrug and just saying, "Oh, you know, I saw this coming. This is what I planned for. You know, this is exactly as I planned." What would be surprising is something that was completely unplanned, maybe. So it's just sort of, you know, a couple of like things of the way math intersects with our life sometimes is also really important to me. And maybe I just find too many parables and metaphors and things. But for me, math is like one of the most metaphorical things, because it is a fundamental truth in many ways, and that you can really grasp that fundamental truth and say, okay, well, now I sort of see the other underpinnings of this in my life. I always joke, I always tease girls that, like, I get dumped a lot for this. I always say that, well, you can't be the most beautiful woman in the world, because, you know, the probability that I've met the most beautiful woman in the world is really, if you think about it, you just start to get a napkin and sketch it out, and the girl's ready to leave. You know, I have to...
And that's exactly why the hot girls don't study math, because people like you piss them off, and now I'm stuck with ugly people. I blame it on you.
Maybe. Well, it was a pleasure talking to you. I hope we stay in touch.
Absolutely.
All right, man.
I'll call in some other time. It was really a pleasure, really enlightening.
Yeah, great.
Thanks a lot.
Nice talking to you. Bye. Oh, sweet.
That was neat.
Yeah, I got a new crush. Hey, Adam.